हेलो बच्चों, तो हम आज का प्रॉब्लम देखते हैं। तो वी हैव गिवन दैट एन atom is in state whose multiplicity is 3 and the total angular momentum is h cross by h cross into 20, root of 20. So we have to find the quantum number L. So as you can see from the question, it's a question regarding the quantum numbers that we know. So the key concepts here to remember is the quantum numbers, individual quantum numbers, what are they given? Key concepts. Here we have to find the quantum number L. So we have to find this quantity L. And we have given the total angular momentum. Total angular momentum J. This is given. Total angular momentum J. And we have a relation between total angular momentum and total angular momentum quantum number small j, which is this h cross. So we have to know the differentiation between j, which is total angular momentum, and small j is the total angular momentum quantum number. That means quantum number associated with the total angular momentum. Clear? And this is the orbital angular momentum quantum number. That is quantum number which is associated to the orbital angular momentum. And we have a relation between the angular momentum and total angular momentum, orbital angular momentum, and there is one more term which we say spin angular momentum. Spin angular momentum and small s quantum number associated with capital S. And we have orbital. If you consider an electron, it revolves around an orbit. So we have an angular momentum and it rotates around itself. And for that, we have a spin angular momentum. Clear? So it rotates around itself and it rotates around the orbit. So we have two angular momentum. One is orbital angular momentum and one is a spin angular momentum. And the addition of both gives the total angular momentum. And we have a relation J is equal to small j, sorry, small j. The quantum number associated to total angular momentum is nothing but L plus spin angular momentum, comma L plus S minus 1 up to L minus S. J cannot be negative. J is always positive. J is greater than or equal to 0. J cannot be negative. So what are we have given? We have given here J, capital J, which is h cross by 20. Clear? So we have to find small l. So I think we have all the information that is required to solve the information. The capital J, that is total angular momentum, and total angular momentum quantum number, spin angular momentum, and this. And we have also given the multiplicity is 3. And we have a relation between we have relation between the multiplicity m and orbit and spin angular momentum quantum number, which is 2s 2s plus 1. Clear? So we have almost all the relation. Now we can proceed for solution. So since we have j, we can find its quantum number directly. J is given as h cross by 20, and we have a relation h cross under root of L plus 1. So on solving, you can easily say that under root of L plus 1 is equal to under root of 20, which implies L plus 1 is equal to 20. So if we solve that, if we take L is equal to 4, then we get J, sorry, J, J plus 1, J, J plus 1, J, J plus 1, J. If J is equal to 4, then we'll get 4 into 4 plus 1 equal to 20. So we get our J is equal to 4. And we know multiplicity M is equal to 3, which is given as 2s plus 1. So you solving this, we get spin quantum number as 1. So we know the small j, which is 4, angular quantum number, total angular quantum number is 4, spin angular quantum number is 1. So we can find the orbital angular quantum number with this relation. J is equal to L plus S up to L plus L minus S. And we also know that the term goes like this, L plus 1 minus 1 up to. Clear? So we know J, we know S. So we'll compare this for the highest value, L plus J. So if J is equal to L plus S, we know that J is equal to 4, which implies 4 is equal to L plus S, which is S is 1, which implies we get L is equal to 3. Similarly, if we consider L minus 1 minus S, which will give 4 is equal to L minus 1, which implies L is equal to 5. So this is the extreme values of L. And if we write the all, if you we have to write all the values of L. So L will be 5, 4, and 3. Since we know that these are the extreme points and this is the intermediate one. These 4 can be found with the help of intermediate one. J is equal to L plus S minus 1, which is J is 4, L plus 1 minus 1 cancel out, so L is equal to 4. So these are the values of L that are possible. L is equal to 5, it can be equal to 4, it can be equal to 3. Hope you understand the concept of different quantum numbers and how we have solved to find the orbital angular quantum number using the expression. Thank you.